Okay. All right, I just chatted. Someone's going to pick a number. They can chat me back the number. I wrote it in the chat box there. And once you choose that number, we'll be able to get started. All right, thank you. Contestant has chosen question number 13. Lucky number 13. Here we go. This is your first number, kids. Let's take a look. All right, I'm going to give you a minute to try and work through this question. This is called a two-way table because you can read it moving across and you can read it moving down. So let's see if you can set up the ratio and chat me your response. A 1, a 2, a 3, or a 4. And then I'll work this problem out for everyone to see. All right, I've got one answer in the chat. I'll wait till I get one more before I start putting up any hints. All right, got some answers. Thank you, thank you. So here we go. We have a chart here that has this many students who were surveyed. And if we add up all of those numbers, we would get a total of 200 students. If we want to know the number of students that prefer pizza, that would be these two numbers. So we're going to add up these two numbers and get 74. So a percentage is 74, the part of the whole. And when I divide that on my calculator, I get this decimal number. And if I want to change it to percent, I would move it 2 places to the right, and it's 37%. Just choice number 2. Thank you for chatting me that response to those kids that participated. Thank you very much. We're going to go back to the game board. Question number 13 was taken, and I see another student already chose a number. And so my third student will be next. We're going with 24, folks. Question number 24. Oh, lucky, lucky question. This is a hidden picture. So the contestants here that are on the Zoom call with me can send me a chat. I will reveal one box at a time. Let's see if you can figure out what picture is hiding behind these boxes. Go ahead and chat me anything you think you might think this is. Be more specific. Chatting me what you think this might be. Do you know who this is? Yay! I'm gonna chat. No clue who it is. Okay. I'm putting in the chat who got it right. And this is who it is. Won a couple of awards last what was it, a couple weeks ago. The awards were on for the music awards. All right, that is Bad Bunny. Okay, we're heading back to the game board. Thank you, thank you, thank you for choosing that question. All right, I've got another player who just entered, but I'm chatting to everyone who should choose the next number. Okay. All right, thank you so much. They chose lucky number 7. Here we go. I am recording this meeting, so I'm not calling out names. So all of my communication to you will be through the chat. Oh, whoops. This is I didn't teach this yet, but I don't know how this question got here. I must have photocopied something wrong. I'm going to skip this question. I'm going to go back. Can you chat me another question there, kiddo? I think that question was from my last file. I must have forgotten to delete it. Okay, here we go. 14 is the next number, 14. Oh, okay. Bella recorded data and used her graphing calculator to find the equation for the line of best fit. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest linear relationship? All right, so go ahead and chat me a 1, 2, 3, or 4. Great. All right, I got all the numbers coming in. Yes, fantastic. Everyone has chatted me a response, and every student is right. So remember, a correlation coefficient that is perfect, like this, goes through 100% of the lines, even if it's going downhill, right? Even if it's going downhill. So it doesn't matter whether you're closer to 1 or -1, just as long as you're closest to one of those. So for us, it is choice number 1, 0.9. Fantastic. All right, that's 14. I'm going to chat now. Telling the student to choose a number. This student is up, and they're going to send me a number. And I'm going to go through back the same order again. All right, so you see me in the chat. They're going to pick a number. And some of these numbers are fun games and some of them are questions. Here we go. 20 is the number. Thank you so much. Here we go. Question number 20. Oh boy, okay. I'm going to give you a few seconds to try and work this out. You can just chat me the number 1, 2, 3, or 4 when you're ready. Okay, I see some answers coming in. If you're working, keep working, but I'm going to start talking for the kids who might be watching this on video and not really sure how to start. So here we go. We have our formula, P1 minus P2 divided by R. And if we want to, let's see, create a formula that cannot be derived, which one of these is not a manipulation of this formula up here? Which one is not a manipulation? All right, so I could multiply both by R, and that would give me RF P1 minus P2. That's what I would get there. And then if I wanted to get P1 by itself or P2 by itself, then I would add P2 to both sides. That would give me RF or FR plus P2. So this one definitely works. Okay, let me back up here. If I wanted to get P2 by itself, what would I need to do? I would need to minus P1 is P1. But then you'll notice that my P2 is actually not positive, right? So if I want to get P2 by itself, I'd have to multiply everybody on this side by -1 and everybody on this side by -1. And if I did that, I'll get negative FR plus P1. And that is what I have over here. I have a negative FR and a positive P1. Okay. So now I'm going to head over here and see what would happen if I got R by itself. All right, if I got R by itself, I would first have to multiply both sides by R to get R out of the denominator. And then if I wanted to get r by itself, I'd have to divide by f. So P1 minus P2 f is definitely one of the answers. Prove these were answers. So the actual answer to this question is 3, because it asked which formula cannot be derived. And that means which one is not equal to this given formula. So the correct answer to question 20 was choice number 3. Right, if you're here on the call and you want to write me something in the chat because you have a question, let me know. Otherwise, I'm going to go back to the game board. That was question 20. And I'm going to go back up here. Chatting for someone to pick a number. So hopefully they see it in the chat and they'll send me a number. Thank you, thank you, thank you. Question 11 it is. Oh, woo, you guys are picking some lucky ones tonight. I only have 3 of these. I only have 3 hidden pictures and you've already found 2. So here we go. Those of you that are here on the Zoom call with me, chat me the name of what you think this is a picture of. Ah, yes. I have 2 correct answers. I just chatted who the first one was, but maybe after this, the other 2. There we go. Yep, almost everybody got it so far. Yeah, it's Mario. I love Nintendo, so that's why I picked Mario. All right, back to the game board. Number 11 is chosen. Number 11 is chosen. So here we go. Next player up, I put in the chat. All right, 16 is the number. Here we go. This one we've been working on lately. Hopefully you guys here on the chat can figure this out. Which situation could be modeled by a linear function? Which situation is a linear function? Okay, thank you very much. I'm getting some chats come in. Flying here. All right, I got 2 correct answers, 2 incorrect answers. So a linear function must have a constant rate of change. That means each time you increase or decrease by exactly the same amount. So if your car depreciates 7%, then the first time you go down 7%. But then the next time when you go down 7%, it's from a different number. So percentages are not the same. Here's an example. If I have $100 and I decrease it by 50%, well, the first time it will go down $50. But then the next time it will go down $25. Okay, see that? So percentages are never linear, never constant rates of change. A gym charges a $50 initial fee, that's this, and then $30 per month, right? Or I could use letter M here, $30 per month. So look at this situation here, and it should feel linear. Y equals mx plus b, right? So that means every month, 30, another 30, another 30, another 30. So that's why this is the right answer. It is a constant rate of change. Doubling is timesing, and linears don't have a timesing pattern. And 0.1% or 7% are exponential. So that's why the answer was 2. All right, back to the board. 16 was chosen. Okay, I think we're up to all right, I just chatted who's next. That person's gonna send me a number. And we'll give the question a try. Okay, 15. 15 is the winner. All right, you guys got this one. This is an easy one. which value would be a solution for x in this inequality? All right, get your scrap paper out. Okay, got an answer coming in. Got a different answer coming in. Okay, all right. I got two of the same answers, and I got one different answer. Waiting for the last student to send me a response. Don't forget the rules, right? For when you are solving. So I'm going to start solving this here. Okay, some people changing their mind. All right, all right. Negative 4x is less than negative 40. When you divide by negative 4, you have to reverse the order, right? You have to reverse this symbol. X has to be greater than 10. What's the question? Which value would be a solution? I'm waiting for some of my participants to chat me again a new answer. The answer is, thank you, yay! The answer is a value that is greater than 10. 10 is not greater than 10. 10 is equal to 10. That's out. Negative 13 is definitely not greater than 10. Negative 10 is definitely not greater than 10. There's only one value up here that is greater than 10. So you guys should have chatted me this one here. All right, I got a couple wrong answers here from my crowd on the Zoom call. So I'm hoping that you are realizing what the question was asking, right? And maybe don't get stuck just on, oh, I just did the math and I got a 10, right? Yeah, a couple of kids chatted me that 10 was the answer. So be careful. The answer has to be a value that's greater than 10. All right, we're going back to the board. Back to the board. I think, yes. Just chatted who's up. It's your turn to pick. That player's going to send me a number. Thank you, thank you, thank you. Player has chosen number 2. Here we go, folks. Ooh. Given the relation R equals the following 4 points, which value x right here would make this relation a function, right? Which of these 4 numbers would make this a function? All right, I got 1, 2, 3. I'm waiting for another answer. Yes, here we go. So remember, for a function, you must have no repeating x values. So if you have a negative 4, you can't have another one. If you have a positive 3, you can't have another one. If you have a negative 1, you can't have another one. Yay! So everyone who chatted me was right. Well done. We're going back to the board. And let's see. All right, next player, your turn to choose. Okay, player has chosen number 4. Ooh, okay, that's a lot of, I wasn't expecting that. All right, different ways to represent data are shown below. Here's the question over here, folks. Which data representations have a median of 2? I'm going to be quiet for 15 seconds. Okay, let's talk about the word median. Some of you might still be calculating, but let's be strategic. Start here. This is the easiest one to determine the median for. The median is this line right here. So the median of this is 2. The median of this is 2. So this one has a median of 2. So this answer has to be wrong because I know that there's a 2 involved. Okay. All right, why don't we check now for number 1? So for number 1, the median or the middle number, right, would be 1 from the top. I'm sorry, 1 from the top, 1 from the bottom. 1 from the top, 1 from the bottom. See, I'm crossing them out. Top, bottom, top, bottom, top, bottom, top, bottom, top, bottom. Right, there's the median. So this one also has a median of 2. So that means these are out. So the answer is either 1 and 2 only, or 1, 2, and 3. So we need to check out number 3. Number 3 is a histogram. Number 3 is a histogram. So we have this many zeros, right? We have this many zeros. So we have a 0. Then we have 3 ones, 1, 1, 1. Then we have 5 twos, 1, 2, 3, 4, 5 twos. Then we have 3 threes, 1, 2, 3. Then we have 4 fours, 1, 2, 3, 4. And then we have 3 fives, 1, 2, 3. And then we have 2 sixes, 2 sixes. Okay. So now what I'm going to do is I'm going to start crossing off from the top and the bottom. So I'm going to cross off 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5 numbers, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 1. The median is 3. The median of this data set is 3. The median of this data set was 2. The median of this data set was 2. So the answer to this question was 1. 1 and 2 only. 1 and 2 only. All right, we're going back to the board. Question 4 has been taken. I have a new student on the Zoom call, so I'm going to chat that student to choose a number. Okay, go ahead, kiddo. You just came in and you're ready to work. So choose a random number for us. Hopefully you can see the chat. I'm not using names, I'm using the chat only. Thank you very much. Student has chosen question number 18. Get your, oh, I can't believe it. You guys found all 3 mysteries. Okay, to the student who just joined us, there's a hidden picture underneath these black boxes. I'm going to start slowly revealing them. Let's see if you can guess what this item is. What? How did you know it already? Yes, I already got an answer. Oh, 2 answers. There we go. 3 answers. You kids are pretty good. Pretty much everybody got it now. Yes, it's a grand piano. It's more like a baby grand piano. It's actually not that big. You know, there are pianos that are even bigger than this. What? That's crazy. Okay, thank you for picking that number. We're going back to the game board. Question number 18 is taken. And I think I'm going back to the top now. I just chatted whose turn it is, so that person's going to choose a number for us. All right, player has chosen question 6. All right, let's read this. One characteristic of all linear functions is that they change by what? Equal factors or unequal factors? Equal differences or unequal differences? So you notice I only read the first words. That's my test taking strategy. It's not to read all of the confusing words. Just start by reading the first words and see if you can eliminate any choices. All right, we're talking about linear functions. Linear functions have plusing or minusing patterns. So that makes them equal or unequal differences, right? So you can't be a factor because linear functions have differences. So the question is, do they have equal differences, always the same number, or unequal distances? Different numbers every time, right? Do they have all the same numbers, equal differences, or do they have unequal differences? Hopefully, yes, yes, yes. I'm seeing the chats roll in. You are correct. For every interval, they should have equal differences, and every interval should be the same. Thank you very much for participating and choosing question number 6. All right. Next player is up. 6 is gone. We got a couple questions left. I'm with 3, 6, 9. We got 12 questions left. All right, next player is choosing a number. I just chatted, and 23 is the quote. All right. Whoa. I want to be quiet while you read. Okay. Which system of inequalities could be used to represent the given conditions? That's the question right there. Before I go back and reread the question, I'm going to look at my choices. See these? They're not exactly the same. I want you to look carefully at them. These two have less than or equal to signs, and these two have greater than or equal to signs. So you can already eliminate 2 choices if you understand what it means to work a maximum of 40 hours. If I can work a maximum of 40 hours, that means 40 is the max. You cannot be higher than 40. You cannot be higher than 40. So that means this is out and this is out, right? You cannot be greater than 40. Not be greater than 40. So I'm going to take those out. And now what we have to decide is this one. The sentences have the numbers in exactly the same places. So really your focus is the vocabulary of the solutions. All right, so let's see. Are we picking 1 or are we picking 3? He can work at least, oh no, he can earn, sorry. He would like to earn at least $250. So $250 is the least number. So you cannot be less. You can only be more. So congratulations if you chatted me a 1. You were correct. Thank you. Thank you. Got a bunch of kids who chatted me a 1. So here we go. Back to the game board. 23 is taken. And we are going with the next player. Just chatted. Player is chosen 21. Woo. All right. The heights and inches of 12 students are listed below. Which statement best describes the spread of these data? So that's the question. The set of data is evenly spread. The median is 59.5. The set of data is skewed because 59 is the only value below 60, or 79 is an outlier, which would affect the standard deviation of these data. Well, if I look at this data, here, I see 60s, I see 70, 60, 59, 60, 79, 60, 60, 60. All right, those numbers are all fairly close together. They're all in the 50, 60, 70 range. So it's not very spread apart. It's definitely not skewed. This word here, definitely out. Not skewed because the data, even though 59 is the only one below 60, it's very close to 60. So it's definitely not skewed. And I think I could just enter all this into my calculator and just figure this one out right away. I can tell if the median is 59.5. So I'm going to turn my calculator on here. Turn this on here. Can you guys see the calculator? Can you chat me? Do you see the calculator? Yes or no? Okay, good. Want to make sure you can see it on the screen. Okay, thank you, I appreciate it. So I'm going to go to my statistics button because this is a statistics question. And I'm going to enter all of my data here. 61, 67, 72, 62, 65, 59, 60, 79, 60, 61, 64, 63. All right, let's see. Yep, I have 12 sets of data. So once you get it in the list, then you need to press the stat button, but instead of editing the data, we want to calculate the data. So we're going to move over to the right, and because we only have one list, we choose number one variable stats, and we press enter 3 times. And now I'm going to arrow down so I can see my 5-point summary. None of this, well, this one is interesting to me, the standard deviation. This one here, 5.6, but I'm going to arrow down and take a look. All right, see that median? It's definitely not 59.5. It's definitely not 59.5. So let's see. I can cross this one off. I can cross this one off. And then we have to see 79 is an outlier, which would affect the standard deviation of this data. All right, well, the standard deviation is 5.6. I'm going to go back to my stat edit. Back to my stat edit. And where this 79 is, I'm going to delete it. There we go. I'm going to delete it. And I'm just going to run the stats again. Let's just take a look. I'm going to run the stats again. Let's see. Run the stats again. Ooh, look at that standard deviation. 3.6. 5.6, 3.6. The set of data is evenly spread. The set of the data is evenly spread. So here's what I'm going to do. I'm going to take a look. Zoom. Zoom. Oh, I got to turn my stat plot on. I'm going to turn my stat plot on. And I'm going to zoom stat number 9. Oh no, invalid dimension. What happened? Oh, I put my wrong stat plot on. I want my stat plot to be this. Okay. Let's see. Zoom 9. There we go. So look at this box and whisker plot I just made. I did it by turning on my stat plot, number 1, by choosing box and whisker over here. And then to view it, I choose zoom stat number 9. Look at that box and whisker plot. Does that look like the data is evenly spread? No. You see that? It's a long whisker over there. So I'm going to say that the 79 is definitely affecting that standard deviation, which I showed you by showing you the standard deviation. But I also showed you with the box and whisker plot. So thank you for choosing question number 21. That was great. I have a couple new kids in the Zoom call now. So I'm going to ask them by chatting them. So hopefully they can see the chat. And that student is going to choose a number for us now. New to the Zoom, but they get to pick a number. Thank you for joining us. All right, question number 3 is up. Here we go, kids. Ooh, we just did this in class. All right. Emily was given $600 for her high school graduation. She invested it in an account that earns 2.4% interest per year. And if you are earning interest, that means you are growing your money. So first things first, this is growth. So if you can eliminate any choices because you know they're not growth, you should eliminate those choices immediately. The next thing we have to determine is which one shows the initial value, the percentage rate, and the time appropriately, right? So we have our initial amount. We have a plus or minus for the rate. We have the exponent for time. So go ahead and chat me your response. If you think you have figured out which one is the growth, which one has the correct rate, and they all have the same time exponent. They all have 4, so that you don't even have to pay attention to. All right, they're out because they are decay. I know they're decay because they have a subtraction sign. So these are out. And now what we have to decide is how many times do you move the decimal point when you have a percent sign? All right, percent sign moves it 1, 2 times. It moves it 2 times. So 0.024 is the correct value. If you chatted me a 3, you are right. Fantastic. All right, I'm going down my list now. Let's see. Yes, yes, yes. Okay. I think we are up to, yes, this person. All right, I just chatted who was next for choosing a number. We're going to go back to the game board. We're going to mark off number 3. And this student has chosen number 17. All right, here we go, kids. This one's going to take some time to figure out. But I'll give you a hint. I would use my calculator. I would use my calculator if necessary. So there are 2 formats you could write your sentences in. You can write your sentence in slope-intercept form, but then they both need to be in slope-intercept form. Or you could write your sentence in standard. Then they both need to be in standard form. So it doesn't matter which form you choose, but they both have to have matching forms. So here's a hint. This one's already in a form. So if this one's already in slope-intercept form, then I might as well manipulate this one to get it into slope-intercept. So I'm going to manipulate this sentence here. And now I'm going to get the y by itself. So I'm going to add 6x sides. And that gives me 3y equals 6. Oh, and then everything by 3. And after I do that, I'm going to get y equals 2x plus 4. Look at that. And look at this. Y equals 2x plus 4. All right, so hopefully you're able to process this now. Maybe you're seeing the answer from what we studied back in 8th grade. But when you have a sentence that has y equals 2x plus 8 and another sentence that has y equals 2x plus 4, that means you both have the same slope. So both have the same rate of change, but one of you has a y-intercept at 4, right? And one of you has a y-intercept at 8. And if you have the same slope, that means you have the same tilt. So these 2 lines are parallel. And parallel lines never intersect, so they have no solution. And if you weren't sure, you could have turned your calculator on. You could have typed it into the y equals button, and you could have figured that out. So I'm going to go here and turn my stat plot off because that ruins everything else. And I'm going to type here 2x plus 8, and then I'm going to type 2x plus 4, And I'm going to put it on that graph. Whoops, my graph's messed up because I zoomed in on my stat. So I'm going to have to, see up here, it's trying to graph. I'm going to zoom standard. If I choose zoom 6, it always takes me back to 10 by 10. And there we go, graph number 1 and graph number 2. And we can see that they are parallel. All right, that was question 17. Cover that up. Let's see who's up. I'm gonna let this kid pick a number. Oops, I typed number wrong, but you know what I'm saying. All right, we got a couple more questions to go. Let's see how many we can get through. 22 it is. Oh, this one requires you to chat me a sentence. State whether 7 minus the square root of 2 is rational or irrational. Hopefully you remember my blanket statement. This statement will work for any rational or irrational question. My sentence. You have to choose one of these. You choose this or you choose this. Yes, somebody chatted me a fantastic answer. So I'm going to wait 10 more seconds. Ringing a bell. All right. So the square root of 2 is irrational. And if you try and take this irrational number away from 7, it will still be irrational. Irrational. So the answer is irrational. And then the explaining part is because it cannot be written as a ratio. That's the answer for every question like this. It either can or cannot be written as a ratio. This one is irrational because it cannot be written as a ratio. Yep, you could also say because it does not terminate or repeat. It does not terminate or repeat, but you stick to this sentence, it's a guaranteed 100. All right, back to the game board. We just have a couple questions left. Let's see. I'm going with this student. All right, just chatted her. She's going to pick a number. It'll probably be one of our last questions. Let's see, number 12. Oh, another one we just did in class. You guys are going to get this right. All right. This is an exponential growth question because she is depositing money, right? She invested it into an account and she's earning interest rate. You earn interest, you have growth. So that one's out and that one's out. She put in 1,000, she kept it for 2 years, but which one of these is the right decimal value? That's the question. 1.3 has a percent sign. So you need to remove this percent sign by moving the decimal. If you chatted me a 2, you got it right. Fantastic. Back to the board. We got time for one more. All right, I just chatted. Let's see, what's the last question we're going to do tonight? This student is choosing question number 5. Question number 5. Ah, all right, this is a pretty good one. This is a good way to end the night. Let's do a little math. I definitely need a calculator for this. So I'm going to write it on the same line. Divide, and I got the same thing that everybody else chatted me. Woohoo! All right, that one was pretty basic. I hope you're feeling good about that one there. All right, guys, there are 1, 2, 3, 4, 5 questions left. I'm going to solve each of them. You can stay on the Zoom call with me if you have to leave. I understand because it is 8 o'clock. But just to finish this video off, since I'm recording it for those that can't attend, I am going to go through these last 5 problems. So if you'd like to stay with me, here we go. Number 1, evaluate this function, 3x plus 4 divided by 2, if we need f of 8. So if you're on the call, you can chat me a response. I'm going to start writing out what should have, and this is go to function f and put in an 8. Okay? So we put the 8 in here. We pick up our calculator, we type this whole thing in. Try not to do the math in your head. You might make a mistake, maybe you won't, but hopefully you're typing this in your calculator and you're getting 28 divided by 2, which is 14. I got a couple kids who chatted me a response. So if you chatted me this answer, congratulations, you enter an 8 into the x position. All right, we're done with number 1. Now we're moving on to question number 8. Ooh, okay. The table below shows the time in hours spent by students on electronic devices and their math test scores. The data collected model a linear regression. What is the correlation coefficient? Okay, I'm going to have to turn on my calculator. I'm going to have to clear out my stat edit button. And I can do that by pressing the delete key, or I can use one of the stat clear features. So here we go. I've got a 3, 1, 4, 0, 3, 7, 5, and 2. 1, 2, 3, 4, 5, 6, 7, 8, 3, 1, 4, 0, 3, 7, 5, 2. Yep, and I'm just double checking because sometimes I type fast and the numbers don't go in. 98, 90, 65, 78, and 90. All right, it already told me that it models a linear regression. So I know that I'm going to calculate the linear regression. But if I go to stat calc and choose number 4, lin reg, it's not going to show me the linear regression correlation coefficient unless I turn on my diagnostics. I'm going to do that in the mode, press the mode button, arrow down to stat diagnostics, turn them on. Once it's on, I can go back to my stat, back to calc, and back to lin reg, number 4. And now I'll get that R value. And be careful, you don't want the R squared value. You want the R value. What did I do wrong here? Stat, edit. Oh, there it is. Look what I did wrong. My second value should have been a 99, and it was wrong. So stat, calc, Ln reg. All right, my correlation coefficient is negative 0.977. So if you chatted me the number 1, you were right. Fantastic. That's how you use the stat diagnostic feature. Okay, question number 9. Solving for a specified variable. This is called transforming formulas. The volume of a trapezoidal prism can be found using the formula volume equals 1/2 A times B plus C times H. Which equation correctly solves for B? Okay, let's start thinking. First thing I always do is recognize this is one term. I'm going to get rid of that fraction. I'm going to get rid of that fraction by timesing both sides by 2 over 1, also known as 2. So I'm already starting with this. Next thing is, if I want to get B by itself, I have to get rid of timesing by A and timesing by H. I'm going to do that at the same time. Timesing by A, timesing by H. So far I've got 2B over AH equals B plus C. All I have to do now is subtract C from both sides. So these are out because they have plus signs. And it looks like 4 is the winner. All right, moving along. Question number 10. Ooh, I don't even need to use my calculator because I already know what shape this function has. We've been doing this. My class has been doing these shapes in September. I asked you on Delta Math to match some things, so this should be a fast one for you. All right, this one is quadratic, this is linear, this one is quadratic, and this one is square root. And if you didn't know that, that's okay. You could always type this into your graphing calculator, into the y equals button by using this absolute value key, square root key, square root of x minus 2. And you could always look at the graph when you type it in here, when you type it in the when you type it in the y equals button. So square root of x minus 2. Look at that graph and boom, there you have it. All right, we're on to our last question. Thank you so much for hanging on with me. Last one. A mapping is shown in the diagram below. This mapping is, okay, let's just look at the first 2 words. A function or not a function. I'm not even going to read the rest. I'm just going to eliminate at least this. This is where you look when you're trying to determine if something is a function. No double arrows. Okay? This is a problem. This is a problem. You can't have one input with 2 outputs. So I know it's not a function. So I'm going to cross these off just so I don't get confused. All right, kiddo, see you later. This is not a function because February has 2 outputs, or it's not a function because 2 inputs, January and March, result in the same output. Nope. The answer here is 3. You can't have 2 outputs for 1 input. And that concludes our video.